So here's a visual representation of what that tuning fork sound looks like. The sound is pitch A, and it's been recorded with Audacity, a free piece of software, which you might be able to install on your computers and investigate different tuning forks for yourself. On the x-axis we're representing time, and here we're looking at the first 3 seconds of time. Look at the shape of that graph. What happens over time? I'm going to play the file again. How is the shape of the graph related to the sound that's being played? And what's the y-axis representing? I want to zoom in on that graph, and in particular zoom in on the x-axis and look at a very, very small instant of time. Here I've zoomed in and I'm looking at approximately 0.3 to 0.4 seconds, a tenth of a second in time. Let's zoom in some more. What can you see emerging? There we're looking at 0.3 to 0.32, 2/100ths of a second of time, a tiny fraction. Let's zoom in some more. Do you recognize this graph? Have you seen it before? Hopefully the answer to that is yes. It's the sine function. But what's the equation? What's the amplitude of that graph? And what's the frequency? And how is that related to the pitch of this tuning fork? That's the investigation, and that's what you're going to try and find out. Underneath this video file you should see some images, and I've taken some screenshots of these graphs and I've tried to put some measurements on there so you can see exactly how far the distances between the two peaks are, and you should be able to read off the amplitude. Your job is to try and reproduce this graph on a graphing piece of software, and then to reproduce some others and to see the difference between them. Good luck.